Welcome back, students. This is the session 3 of wave optics, and the topic is refraction of a plane wave. So, in order to save the time, I have already drawn one figure here in which I have depicted the incident wave front AB, um, which is incident on the interface PP dash. Interface is the surface which is separating the medium 1 and medium 2. So the incident wavefront AB is getting refracted into the medium 2. The angle of incidence is I, which I have depicted here, and the angle of refraction is R. The refracted wavefront is CD. The incident plane wavefront is AB. V1 is the velocity of light in the medium 1, and this is the medium 1 and this is the medium 2. PP dash is the surface which is separating the medium 1 and medium 2. This V1 is the velocity of light in the medium 1 and V2 is the velocity of the light in the medium 2. So here you can see that the direction of this incident wave front is A dash A, and it is depicted by this arrow. The angle of incidence is angle of incidence I is equal to angle. This is the angle A dash A N, A dash A N, and this is equal to I. Now the angle of refraction is N dash A D. Angle of refraction is angle N dash A D, and this is equal to R. So angle of incidence I is equal to angle A dash A N, which is equal to I, and the angle of refraction is angle N dash A D, which is equal to R. Now here N dash is the normal to the surface PP dash, which is the surface which is separating the medium 1 and the medium 2. So if this angle is I, then this A dash, since A dash AB is equal to 90 degrees, so this angle, that is NAP, will be equal to 90 minus I, which I have already written here on this board. This is equal to 90 minus I. And since NAC is equal to 90 degrees, so this angle, that is BAC, will be equal to I. So angle BAC is equal to I, and since angle N dash AD is equal to R, so now N dash AC is equal to 90 degree. So this angle, that is DAC, will be equal to 90 minus R. So this is 90 minus R, this is 90, so this will be equal to R. That is angle ACD. Angle ACD will be equal to R. So sin I will be equal to perpendicular upon hypotenuse, that is equal to BC upon AC, and sin R, this sin R will be equal to perpendicular upon hypotenuse, this will be equal to AD upon AC. So it implies that sin I upon sin R will be equal to BC upon, this is BC upon AD divided by AD upon AC, so we will be getting as BC upon AD. Okay. Now, if T is the time taken by the wavefront, that is the incident wavefront. If T is the time taken by the incident wavefront to travel the distance BC, this distance, So BC will be equal to V1 into T, because V1 is the velocity of the light in the medium 1 and T is the time taken by this wavefront to travel the distance BC. So now this is the incident wavefront and CD is the reflected wavefront. Therefore AD will be equal to V2 into T, where V2 is the velocity of the light in the medium 2. So if I substitute these values in this equation, that is, let us say this is equation number 1. If I substitute these values in equation number 1, I will get sin I upon sin R, which is equal to V1 into T divided by V2 into T. This is equal to V1 upon V2. Okay, so sin I upon sin R is equal to V1 upon V2. Let us say this is equation number 2. Now, now if C is the velocity of light in vacuum, N1 is the refractive index, of medium 1, and N2 is the refractive index of medium 2, then N1 is equal to C upon V1 and N2 is equal to C upon V2. If C is the velocity of light in the vacuum, N1 is the refractive index of this medium 1, N2 is the refractive index of medium 2, then N1 will be equal to C upon V1 and N2 will be equal to C upon V2. Now I will be using this relation and this equation number 2 in order to derive the Snell's law. So I will be now writing this equation here for reference, that is sin I upon sin R is equal to V1 upon V2, and this was the equation number 2. And this was the equation number 2. So from here, from these two equations, that is N1, if N1 is equal to C upon V1 and N2 is equal to C upon V2, it implies that N1 V1 is equal to N2 V2, which is equal to C. Or it implies that V1 upon V2 will be V1 upon V2 will be equal to N2 upon N1. Let us say this is equation number 3. So, now I will be substituting this value in this equation number 2, or you can say combining equation number 2 and 3. We get sin I upon sin R, which is equal to V1 upon V2, which is equal to N2 upon N1. Because here V1 upon V2 is equal to N2 upon N1. So sin I upon sin R is equal to V1 upon V2, which is equal to N2, which is equal to N2 upon N1, and this is the equation number 4. Okay. So I'm writing here the refractive index of this medium is here N1 and the refractive index of this medium 2 is N2. So from this equation 4 we can see that, or we can write that N1 into sine I is equal to N2 into sine R by cross multiplication. So by cross multiplication, N1 sine I is equal to N2 sine R. And this is called the Snell's law of refraction. This is the Snell's law of refraction. This equation number 4, that is sine I upon sine R, which is equal to V1 upon V2 is equal to N2 upon N1. This is an important relation and it will be utilized in a number of questions which we will be solving in the forthcoming sessions. And N1 into sine I is equal to N2 into sine R. This is called the Snell's law of refraction. Now, this equation, that is the equation number 4, can be can also be extended in terms of or we can say that this equation number 4 can be further modified in terms of the wavelength of this light in the medium 1 and the medium 2. So let us say if lambda 1 is the wavelength of light in medium 1 and lambda 2 is the wavelength of light in medium 2. If lambda 1 is a wavelength of light in the medium 1 and lambda 2 is the wavelength of light in medium 2, and if BC is equal to lambda 1, that is the distance traveled by this incident wave front, that is this distance BC traveled by this wave front, if it is equal to lambda 1, then AD will be equal to lambda 2. That is, and what I am here I have considered the wavelength of the light in medium 1 as lambda 1. I am here writing it here again. Either it's lambda 1, and here the wavelength of this incident. This is lambda 2, and this is lambda 1. If the wavelength of the light in the medium 1 is lambda 1 and if the wavelength of the light in medium 2 is lambda 2, then, and if BC, that is the distance traveled by this incident wavefront, BC is equal to lambda 1, then AD will be equal to lambda 2. Okay? So, or we can say that, so we can, or it implies that lambda 1 upon lambda 2 will be equal to BC upon AD. Now, BC, we have already calculated that if T is the time taken by this wavefront to cover this distance BC, then BC was equal to V1 into T and AD was equal to V2 into T. So, and this was equal to V1 upon V2. So, if the wavelength of the light in the medium 1 is lambda 1, and if the wavelength of the light is equal to lambda 2 in the medium 2, and if BC is equal to lambda 1, if this is equal to lambda 1, then definitely AD will be equal to lambda 2. So, lambda 1 upon lambda 2 will be equal to BC upon AD, and this will be equal to V1 upon V2. So, now this equation 4 can be modified further as I will be writing, I will just rub it and then I will write it again. That is sin I upon sin R, this will be equal to V1 upon V2, and this is equal to N2 upon N1, and V1 upon V2 is equal to lambda 1 upon lambda 2. So this is a very, very important relation which needs to be remembered by all of you, that sin I upon sin R is equal to V1 upon V2, this is equal to N2 upon N1, and this is equal to lambda 1 upon lambda 2, where lambda 1 is the wavelength of light in the medium 1, lambda 2 is the wavelength of light in the medium 2, N2 is the refractive index of the medium 2, N1 is the refractive index of medium 1, V1 is the velocity of the light in the medium 1, and V2 is the velocity of the light in the medium 2. Sin I is the angle of incidence and R is the angle of refraction. So this is a very, very important formula, and based on this formula, we will be able to solve a lot of questions in the forthcoming sessions. So thank you very much for joining this session, and in the next session I will be taking up a couple of questions based on this relation. So till then, have a nice day. Bye.